Okay, 28 is a word problem. It says Fantastic Flags Inc. finds that the cost to make X flags is C equals 32X plus 18,695, while the revenue produced from them is R equals 36X. C and R are in dollars. What is the smallest whole number of flags X that must be sold for the company to show a profit? That's our question. What is the smallest whole number of flags that must be sold for the company to show a profit? If you want to show a profit, then the money that you bring in better be more than the money you spend to run your business. Revenue has to be greater than your cost if, whoops, hang on, don't know why this is not erasing. There we go. Revenue has to be greater than cost if you want to make a profit. All right, revenue has to be greater than cost. Now, up in the word problem, it said that revenue was right here. R is 36X. And my cost was right here. Cost is this. So, I'm going to put the 36X here, and that is greater than the 32X plus 18,695. And now all I have to do is solve for X. Now, on word problems, I told you you can use your graphing calculator capability, or you can just go with the algebra. It's up to you. I'm looking at this and I'm like, I am team algebra all the way. So I've got X's on both sides, but on the right side, I have this 18,695. So I'm going to make all my X's be on the left. And so I am going to subtract this 32X to cancel it out. But then I've got to subtract 32X on the left. And that's going to leave me with a 4X. And now 4X is greater than 18,695. And now you got to get rid of the 4. And since 4 is multiplied onto X, I shall divide it off, because 4 over 4 would be an invisible 1X. But what you do to one side, you got to do to the other. So when I actually divide, I get 4,673.75. Well, obviously you cannot sell 0.7 of a flag. And the question did say, what is the smallest whole number of flags X? So because I've already gone past 4,673, even if that had been 0.05, you're going to round it up to 4,674 flags. You would always have to go up so that your revenue will be greater than your cost. Okay? It's going to have to go up. Because if you go down, revenue would be less than cost. So, that's my answer to number 28. And I think I'll go ahead and do number 20. Yeah, I got time to do it. 29. 29, assume the math model C of X equals blah, blah, blah represents a cost C in hundreds of dollars for a certain manufacturer to produce X items. How many items X can be manufactured while keeping costs between, there's two betweens in here, sorry about that. Take that one out. Between 5,200 or 526,000 and 782,000. Okay. This problem is a little sneaky because let me go with purple. Because it says C of X equals 16X plus 140 represents the cost C in hundreds of dollars. Okay. These two numbers are actually in thousands of dollars. I have to convert my thousands into actual hundreds, and literally the way I'm going to do that is, let me pick a different color, how about blue, is take these two numbers and divide them by 100. So I'm going to have 5,260 hundred at one end, and then at the other end 7,820 hundred at that end. And it's going to be, remember, it's going to be between, so it's going to be a less than here and a less than there, and in between would be your costs, right? Costs would go in between, and costs are here's my costs right here. This 16x plus 140 goes in between. Those are my costs. And now I have one of those things that I like to call an in-betweeny. So I'm going to subtract the 140 to cancel it out of the middle, but you have to subtract the 140 at either end also. Don't forget to do that. And when I do that, down here I get 5,120. At the other end I get 7,680. But in the middle, you're now down to just the 16x. Now get rid of the 16. Since it's 16 times x, I'm going to turn around and divide, because 16 divided by 16 is an invisible 1x. But I have to divide 16 on either end as well. And that's going to give me 320. Oops, wrong color. Sorry about that. Come on, erase. Oh, there we go. That's going to give me 320 on the left, 480 on the right, and the x in the middle. And x is the number of items. It says how many items x can be manufactured while keeping costs between those two numbers. So my answer is going to be between 320 and 480 items. Whatever it is they're making. That is what will keep the costs between 526,000 and 782,000. Okay. Sorry about my goose, but hopefully that makes sense.